Hello, everyone. We are glad to welcome you at our webinar. My name is Stacy. I represent Vettabase, and our today's topic is MariaDB temporal tables. The speaker is Federico Razzoli, the founder of Vettabase and the author of Mastering MariaDB book published by Pact. Just some housekeeping notes. Please ask questions in the corresponding tab of the interface, and Federico will answer them after the demo is over. The recording will be sent your way after the webinar, and you will be able to revisit what's important for you. And same for the slides. We will place them on SlideShare for your convenience, and you will be able to have a look at them and probably download as well. And now I will ask Federico to start the presentation.
Hi, everyone. Hi, Stacy, and thanks for the introduction. So, as Stacy said, welcome to our webinar on MariaDB temporal tables. So this is the typical slide that tells you if you are in the correct webinar or not. So this is the agenda of this webinar. We will talk about, first of all, briefly talk about why we want to track data changes, and then the 2 or 3 types of temporal tables in MariaDB, which are system version tables, application period tables, and bitemporal tables. And then there will be a final word on another technology which could be used in combination with this, with what I'm going to show in the webinar. So let's start, of course, with why we want to track data changes. Well, there's a variety of reasons. It's impossible to list them all, depends a lot from case to case, but some common reasons could be, first of all, data auditing. We want to know why we have certain data, when they were inserted. And we should also check by whom they were inserted. But, or for example, who deleted some data. Of course, this means that we should add some more information that is not only the timestamp that we find in temporal tables. We should add at least the username of the person who made the changes. We can travel back in time, which means we can check what was the situation of our organization 1 year ago, for example, or we can make comparisons between different points in time. So we can see which customers and products and services we have now and which ones we had 6 months ago, 1 year ago, and so on. We can make statistics on how data changes, how many new users, how many users leave, how many characteristic changes in our users. For example, if they change their subscription type or stuff like that. We can find correlations between data, for example. Well, this is a bit more complex. I won't show this in the webinar, but we could, for example, find out that we are selling less services because we are investing less in marketing, for example. And we can check the history of an entity, for example, the history of our relationship with the customer, the history of our products or employees or whatever. And of course, it can also be useful for debug reasons. This is similar to auditing, except we focus on finding out how we ended up to have certain data written by the application. Okay, maybe there is some bug in the application. We don't know why it is basically messing up some data. So there are many ways to track data changes, at least 3 different ways, actually. Most commonly, well, what happens is that you want to send data to analytics, not necessarily analytics, it could be a message queue or something else, actually. But analytics is the most common case. So maybe you have a consumer which reads the binary log, finds data changes, and sends them to another technology, for example, Kafka, or maybe Google Data Stream, or whatever. And then this data will be sent to other technologies for analytics. Okay, this is great. I mean, if we need to do analytics, the best thing we can do is to use a technology built specifically for analytics, not MariaDB, not another similar database, but something more specific. But the problem is this doesn't serve all use cases. For example, these changes are not available to the application that wrote the data. Okay, I mean, they would be available if the same application also connects to technologies for analytics, but that never happens, right? It would be a bit crazy. And also these changes are replicated asynchronously. For example, data pipelines often break, and when it happens, data is not replicated for a while. But even if they don't break, maybe data is only moved by night, or maybe even once a week. So we will not see the changes immediately in our analytics. So we may want to do some in database data changes tracking. And basically, we can do these with triggers or with temporal tables. With triggers, basically, we have 2 methods. For example, if you use MySQL, you don't have temporal tables. You have to use triggers. And then you can do one of the following things. You can log the versions of each row into a specific table, or you can log each individual value change. So basically every row column that changes. Okay, and I can show an example actually. I hope you've noticed that Stacy posted a link to a GitHub repository. You can find the examples there too. But anyway, I hope you can also see them in my screen. So this is an example of versioning the rows. Okay, as you can see, we have a user table. Then we have a user history table, which is meant to log the versions of each row in user. Okay, whenever a row changes with update, a new version is created. Okay, so these are the triggers that will keep these tables in sync. So every time we insert a row in user, another row will appear in user history. As you can see, we also add two timestamps, right? Valid since and valid until. Valid since is now because we are inserting the row now. Valid until, in this case, is a date in the far future. Actually, this is the highest possible date that, sorry, the highest possible date that we can store with a timestamp data type. On delete, what we do is basically changing the valid until timestamp in the user history table. Okay, so basically we don't delete the version, but we record that it stops being valid now. And update is just a combination of the other two triggers. Okay, first we record that the old version of the row is no more valid, and then we insert a new row. Okay. I don't have the time to run all the examples, unfortunately, because this is just a 1 hour webinar. But you can find as I said, you can find the examples in the repository and you can try them. And you can probably play a bit with them and make some changes. The other method is versioning each value, basically. Okay, so in this case, we have user and user change. The user change table has, okay, primary key, a UUID of the row change, which basically will be the same for multiple values if we are going to change multiple values with one statement. Okay, so it identifies the SQL statement that we're running. The name of the column that changes the old value. Okay, we don't record the new value, but the new value is written in user. Okay, of course we could also write the new value if we want to. In my opinion, it's a waste of space, but this is just my opinion. There is no universal truth. Okay, if you prefer to record the new value, you can do it. Valid until, of course, which indicates when this version of a value stopped being valid. Okay. Well, I'm not going to discuss every detail of the triggers, but you can see them. They are pretty simple. And basically, yeah, they write a separate row into user changes for every column that we are versioning. We can even decide, for example, not to version some columns. But anyway, again, if you want to try, you can also find the examples or tests at the end. Okay. The main problem is this stuff is very hard to maintain. If we add one column, we will have to modify 3 triggers. And when we deploy the change, it will be difficult. We will have an inconsistency in our database for some sequence, okay, because we have one more column, but it's not yet mentioned in the triggers, okay. And also, triggers are not really super fast in MariaDB, to be honest. They are not as fast as they should be. And they are also I mean, I won't say they are a huge problem for scalability, but they could be because they acquire some locks. So temporal tables are better in this respect, right? Because the logic of the versioning is transparent. It's already implemented in the in MariaDB. We don't have to write triggers to explain how to version the data changes. The rotation of old rows can also be automated. I will show this very briefly. Also, they are faster and they are more scalable. So let's do a temporal tables overview. Okay. First of all, well, where are they implemented? Interestingly, they are almost missing in open source databases. They were implemented in Oracle, IBM, SQL Server, Snowflake. But when it comes to open source databases, well, PostgreSQL doesn't have them. They have an extension. I have seen that there is even an attempt to rewrite this extension as a PL/SQL library, but it's not a native feature. MySQL doesn't have them at all. They are in CockroachDB. They kind of are supported by HBase, sorry, and CrookDB. I'm not sure it still exists, but if CrookDB still exists, well, yes, it supports by temporal tables. MariaDB implemented them in version 10.3 and 10.4, which are a bit old now, so they are well tested now. They have been improved since then. Even in the latest long-term support version, 10.11, there are still some improvements to temporal tables. Hopefully more improvements will come. By the way, you can see 10.3 implemented system version tables and 10.4 application period tables. I'm going to explain what this means. And the table can also have both these characteristics. In this case, it's called a bitemporal table. So let's start by system version tables, but this is just a quick overview of system version tables. I will talk about them in a moment, and I will show some examples. By the way, just to give you an idea, a system version table means that its rows are versioned. Every row, they are automatically versioned. Okay, whenever I insert a new row, I'm creating a version of a row. When I delete a row, I am modifying that version of the table of the row. Every row has two timestamps: the start and the end of the validity of that version. As I said, timestamp modifications are transparent. We don't need to do it manually. Actually, we can't, and that's normal. I mean, if we could, we could mess up the history of data, and that's not allowed, of course. They are compatible with regular table, or if you prefer, they are compatible with your existing applications, because a normal select will only return current data. It will not return the history. But if you use special syntax, you can query the past data. Okay. Application period, well, they are different. They are not automatic. Actually, if you don't use temporal features, an application period table is just a normal table. Okay, there is no difference basically. But you can use some features to handle in an easy way, easy and powerful way, periods of time. Okay. It works well if you have a table that describes a range of time. Okay, for example, you might have a table with reservations for a hotel. This is actually the example we will use. A reservation is a period of time. Okay, one can make modifications to this period of time, making it shorter or making it longer, and these kind of things are made easy. So, okay, sorry, let's skip this. System version tables. Okay, I will show you very quickly the syntax to create a table, just to make you understand what you can do. And then I will show you examples. Okay, I won't stay long on these slides. So this is a create table for a system version table. Okay, you can have several columns definition, and then you have to decide. Well, you don't really have to, but you should specify 2 timestamp column. You can use this syntax. One is for the row start, and the other is for the row end. Here, I use the invisible keyword, but it's not mandatory. It's only something that I suggest to do, because if these columns are invisible, this means that if I run select asterisk, I won't see them. So the results will be completely compatible with existing application. Okay. If applications are not written to use these columns, you can make them invisible, and you will have maximum compatibility. And then there is this probably redundant syntax. I have to repeat the column names and with system versioning. I say that you don't have to specify the columns, because if you don't do it, this will happen automatically. But the problem is you don't know the names of these columns and you can't use them in any way. Okay. If they exist but they are invisible, you can use them if you mention the columns explicitly in your queries. And when you're going to read historical data, it will be very convenient, because it means you can do it without using any special non-standard or non-ORM friendly SQL syntax. Well, here in these slides, I'm just repeating the same things actually, so let's skip it. I wanted to show you that you can also modify an existing table and make it system versioned. Okay, it's very similar. I'm adding 2 columns, timestamp columns with the same characteristics. I'm adding period for system time, and I'm specifying add system versioning. Well, some more best practices. Making some tables system versioned is not risky, but at the same time, in a database, everything is potentially risky, right? So, I mean, there are not scary risks that you might run. But of course, something could go wrong. For example, you could fill the disk. So you might want to do this in a prudent way. So what you can do, for example, is to attach a new replica to the existing master. And in the new replica, you can make the tables system versioned. This works. Replication will not break. And you can basically use that replica for any temporal tables related task. For example, if you have analysts that want to be able to run queries manually, they can do it. They can connect to that replica, and they will not affect the master in any way. Once you're confident enough, if that is what you want, you can make the change on the master too. In both cases, for new tables or for existing tables that turn into system version tables, it could be practical to create one or more partitions for historical data. Why? Well, essentially for better performance, because most queries normally read the current data, and it's better if historical data is written into separate partitions. Okay, otherwise the table will be big, the indexes will be big, and the queries will be slower. Okay, one partition could be enough, but you can write. Sorry, you can have more than one historical partition. Here I show you the syntax. There is this special syntax partition by system time. Okay. But there is also another way, and I didn't write it in the slide for some reason, but I will show you when I run some examples. You can also delete historical data. Okay. Okay, there are several ways depending on how drastic you want to be, but basically, most commonly, you will run this command, the first one, delete history from table before system time, and then you specify a timestamp. So, as I promised, let's see some examples. So the examples for system version tables are in the sysver.sql file. Okay, I don't need to run these create tables, right? Because the tables are already created in this database. Sorry, the database name is temporal tables. So I'm going to use it. Sorry. And I'm going to run show tables. I have, oh, actually, no, I didn't create product category, but I created user. There is a reason for that, because user has a good quantity of data, so I needed to do it before the webinar. Okay. In this example, okay, as you can see, I created a normal table, product category, and then I'm going to use the syntax I already shown to make the table system versioned. Why? Well, because most tables are made system versioned in this way because they already exist, and when you at some point need to version your data, you start to do it in this way. Okay. Well, as I said, there is also a better way to create partitions. Well, actually, I can put the real table name here. I can partition by system time, but I can also specify two things. The interval of each partition, in this case, each partition will be 1 month, and I'm going to keep 12 partitions, so 1 year of data. As you can see, it's mostly automatic. We don't need to use complicated syntax if we don't want to do something very, very, very specific. Now, first of all, let's do some basic demonstration. Okay, if I select all data from product category, okay, I only see the primary key. Actually, I suggest to use UUID rather than ID as a primary key, and the category name. Okay. Of course, I can do something more because I know that there are valid scenes and valid until columns, which are again invisible. Okay, so they are invisible. So the previous query didn't show them, but this query mentioned them explicitly, so I can see them. Okay, I could even mention them in the where clause or in the order by clause. So even if they are invisible, they are fully usable. Okay. Now we can see, for example, the deleted rows. How can we do it? We specify this syntax. When we specify the table name from product category, we also add for system time all. Okay, I suggest to only use this specific syntax for working with temporal tables, and do everything else with where clauses. I find it better because it's just plain SQL with one more clause. Okay, there are also some more exotic syntaxes, but they are not more powerful than this. They are just I don't know, fancy, I suppose. So if I, oops, I don't know. Oh, sorry, I know what happened. I copied a row by mistake. Sorry about that. I'm going to run this. Oh, okay. No rows are deleted yet, but I can delete one just to make a test. So delete from product category. Let's use copy paste where UUID equals. Let's copy this. Let's delete comics, for example. Okay. And then I can show again deleted rows. And I can see comics. Okay. So, well, another way, I only show this for the sake of completeness, but well, you could do it if you put all the history in a single partition. You could use this syntax to only select data from the historical partition, and then you will see deleted rows. But anyway, it doesn't really matter now. We could see the rows deleted more than 1 year ago. We simply use this syntax, okay, where valid until less than now minus interval 1 year, okay. 1 year ago, the table didn't exist, so I'm not going to try, but we could. Or we can see the rows that were deleted in a certain day, okay. Well, I could use a simpler syntax, but for performance reason, I suggest to use this syntax, which can use an index if there is a suitable index. But anyway, it doesn't matter. I hope everyone understands this where clause. If not, feel free to ask, please. Then we create a user table. Well, I already shown this in the slide, and as I said, it already exists in the database. So I'm going to show some examples of queries that I can run to make certain analysis on this table. Okay, so for example, I could compare the situation in 2 different points in time. Okay, I mean, I already shown how to see the past, but I could check, for example, the difference between now and the first day of May 2023. How do I do it? Simply with a join. Okay. If you read the comment, I've been a bit more specific in the request. Okay. I want to see the number of current customers that started a diamond subscription, whatever it means, in or after May 2023. So to do this, I'm going to simply do a join between now and a past date. Okay. The on clause is obvious. Okay. Of course, I joined the rows by UUID, which is the primary key. I'm using a where clause to specify that, first of all, I only want to know the rows that didn't exist in the past. Okay, so where past UUID, sorry, the opposite. I mean the rows that existed in the past. So I'm checking the rows where past UUID is not null, and then I make the conditions on the subscription type column. Okay, so I can try it. Well, probably the result will be empty, but oh, sorry, I did it again. Yeah, it's empty. Sorry about that, but it doesn't matter. You understand the logic. I can see the history of a single customer, for example. Okay, I already mentioned this at the beginning. So what I will do is I select all columns plus the 2 invisible columns. And I also want to know the difference between the 2 timestamps. So for each row, I will see for how many days it remained valid. Okay, from user, then I use the for system all syntax. I specify a single UUID, and of course order by time, otherwise it would be unreadable. Now let me try. Okay, there are many columns, so I'm visualizing it in a vertical way. If you're not familiar with my MariaDB command line client, you do this by ending a query with / uppercase G. Anyway, now you can see all the changes to this specific customer. Okay. For each version, I can see when it was valid. Okay. These are the timestamps, and I can see all the columns for that version. In the last version, the valid until timestamp is, it's actually a past timestamp from this year because the row was deleted, I guess. Sorry, let me check. Yes. So, or I can see something more interesting. I could see the history of a single column. Okay, but why is it more interesting? Because the query is a bit more complicated, of course. Why? Because if I look at a single column, I don't want to see many versions in which the column didn't change its value. Okay, it would be hard to read. Okay. And I can't use distinct because I'm not only selected. I'm not only selecting that column, but also the timestamps. So every row is distinct, of course. So using select distinct wouldn't help at all. So what I'm doing is using the log function. It's a window function, as you can see. If you're not familiar with window functions, I will tell you briefly what it does. It returns the previous value of the columns I'm passing, subscription type in this case. Okay, and it reads the rows in a certain order, of course. So I'm specifying valid since. But the problem with this is I can't use this window function in the where clause. So I have to do something slightly more complicated. I have to run an outer query, which selects data from the inner query. And then in the outer queries where clause, I am inputting two conditions on the results of the log function. Okay. So basically, I want to check that the row value and the previous value are different. And here's what I'm going to see. You can see I have less results because I only have the results where the value of subscription type is different. So in the first version, the user had no subscription. Previous subscription type is null because it's the first row. Then at some point in this date, the user had a silver subscription, and in this date, it had a gold subscription. Okay. So I can also see the result of the history of a single row. Sorry, of a single column. Very handy, but what else can I do? Well, I can find, for example, the rows inserted in the last month. Well, I already seen something similar, but anyway, let's do it. Okay, apparently only one was inserted in the last month. I can find the rows that, oh no, sorry, I should explain this actually, because I'm not just checking which rows existed last month or something like that. I'm checking which rows were inserted. And again, I'm using the log function. Why? Because if I see several versions of a row, how can I tell when it was inserted? Well, an obvious answer would be I'm checking the timestamps. The oldest version is when the row was inserted. Yes, but suppose we rotate data and basically once a year we delete all the data. Maybe the user subscribed 10 years ago. So I don't have the first version of the row. I mean, my first version of the row is not when the row was inserted. Using log should tell me basically I'm using the log function to look for a null value. Okay, so let's do it. Anyway, I mean, even if we never rotated the data, this can be useful because I think it's actually the easiest way to find Okay, in this case, I only find one rows, but maybe there are hundreds, and I don't have a specific UUID to query or some more restrictive criteria. So I only want to check where the previous rows doesn't exist. Right? I think it's the easiest way. Not the only way, but probably the easiest. If I want to check for the deleted rows, it's the opposite, of course. I'm going to check the rows. Well, first of all, I'm using the lead function, which is the opposite of log. Okay, lead returns the next value of a column. Okay, so the value from the next row. So I'm checking where the result of lead is now, and it is less than now. Okay, because otherwise it could be a value in the future, which means that the row was not deleted. But actually, I want to find the last version before it was actually deleted. So I'm going to run this. Oh, okay, I'm finding nothing, but well, it's a small data set, so it's very possible actually. I can do some statistics on how often rows change, or actually in this case, it's not rows in general, it's one column. Why would I want to do that? Well, first of all, in other cases, there could be a reason to know that. But in this specific case, I'm going to use this information for fraud, for a very, very simple, actually oversimplified version of fraud detection. Okay. Let me show you. First of all, I want to know how often emails change, for example. Okay. So I can see that by average, they, what is the interval of time? 6 months. So I can see that by average, they changed once in 6 months. Standard deviation is very small. The minimum is 1, the maximum is 3. Okay. But now, for the purpose of fraud detection, I mean, of course, fraud detection should be done in better ways. If possible, using graph databases. But anyway, suppose I don't have that, and I want to do some simple checks. Okay, so in this case, with this information in mind, I can see how many times an email changed, in a specific email changed in the last 6 months. So I'm going to run this query, which is pretty simple, and it tells me 3. So this particular user changed their email 3 times. Okay, in this case, well, maybe I already have some suspects about a particular user, but I might want to extend this check and see the rows that changed their email most often. Okay. In this case, we don't have any suspect case, but as you can see, well, it's a simple query with group by. I can explain things if you ask me questions, but probably everyone understands group by, and we're adding a having count more than 1 because, I mean, I don't want to see the row where no change was made. Okay, you can see only these 2 cases. Well, nothing suspect, but maybe if there was another row with, I don't know, 20 changes, it would be a bit strange. I could see, for example, persons who share the same IP or shared the same IP at different points in time. Well, the query is pretty simple. Again, I'm not going to explain unless someone asks me to do it. Okay, I don't see anything, but anyway. Again, this is something that you do much more easily with a graph database, but you can do it. I mean, it's a simple query. Now, I want to do something maybe a bit more interesting. It's the last example. I want to know the number of subscriptions by month and by type. And to do this, basically, in this inner query, I'm selecting a sequence of months. In case you don't know, I'm doing this with MariaDB special storage engine called Sequence. Sequence doesn't have any physical table, but it returns a sequence, okay? Which sequence? Well, I decided by specifying it in the table name. So this table doesn't exist, but the name starts with sec. Sequence will jump in and understand my request. Okay, it's a kind of virtual table. Okay, I can see the numbers from 1 to 12. Okay, and if I do something like this, I will add the year basically. Or I did this just to have the rows ordered, but the point of this query is actually with rollup. If you are a data analyst, you surely know what it is, but basically it's just a way to get summary rows. Okay, I run a group by and then I get summary rows. It's better if I show it and then it will be easier to explain. You can see I'm selecting the various month. Okay, for each month I can see the existing subscription types and how many of them I have. Okay, it's pretty simple. But for each group, there is also a null row, which is added by with rollup. Okay, this is the sum basically. It's a sort of rolling sum, and in the end, I have a total sum. Okay. In this case, probably I don't really care about the total sum, but I care about the sum month by month. Okay, so that was the last example. Actually, it took a bit too long, maybe because I still need to talk about application period tables, but I'm not going to talk a lot about this because I think they are a bit less useful. And the case where they are mostly useful, in my opinion, is where you use a combination of system version and application period tables, and this will be shown at the end. By the way, so talking about application period tables, I can create them with this syntax. It's a bit more simple. Basically, I add this row, period 4, and then I decide a period name, and then I specify two temporal columns. In this case, they are dates. They could be date, time, or timestamp. Okay, I'm specifying a period name. Actually, I have to do it, but I have to tell you that this doesn't mean that I can have multiple periods. I mean, for every table, I can have only one period, unfortunately. But of course, it's more than enough in most cases. This particular table in this example is a reservation table, right? Reservation for bungalows. Well, I will show this in an example briefly. Sorry. Okay, instead of showing you the syntax, I will only show you the examples. Sorry. Oh, yes, period SQL. Okay. So this is the table definition. Actually, it's not populated by a lot of data, so I'm going to rerun this. The database is period, so I'm going to use period. Okay. I recreate the table because, as you can see, I'm using this MariaDB syntax: create or replace. It's very convenient in some cases. I don't remember why I kept these separate, maybe just to show it separately, but basically I can optionally decide that I don't have overlaps in my time ranges. What does it mean? Okay, I'm adding a unique index where the main column is bungalow name. Okay, so for the same bungalow name, I can't have the same reservation value. That's why I specified without overlaps. And it is truly unique. So, I mean, I can't have identical ranges, but I can't even have ranges that intersect each other. Okay, otherwise it would be strange. I mean, otherwise I could have two different clients that booked the bungalow for the same day. Okay, I don't want that. So I'm going to run this. Oh, there is one thing I will tell you in a second. It's important to note that I added start date to the primary key. There is a reason for that, because otherwise, when I run certain operations, I will have duplicates here. Okay. It's basically not what I want. Okay, I want to be able to run all operations. So let's skip this and let's do the demo. Okay, so I'm inserting some data into this reservation table. It's not a normalized table, so but it's a table that is probably good for examples, right? Basically, instead of having a separate table for bungalows and for customers, I have their names written directly in the table. Okay, and what I have is very simple. I have a bungalow called Yellow House and another one called Green House. Yellow House is booked in the first half of August by John Coltrane, and in the second half of August by Charles Mingus. And Greenhouse is booked for the whole month by Ornette Coleman. Apparently, it's a service for jazz musicians. Anyway, what I'm going to do now is to check if my unique index works. Okay, so I'm going to try to insert a reservation for Thelonious Monk, for the Greenhouse, in the last 2 days of August. Again, someone else booked the whole month, so I shouldn't be able to do this, right? Let's try. Right, I get an error, which is exactly what I wanted. Again, this is possible because I used, sorry, I can't find it now, add unique without overlaps. Okay. So now let's see what happens if I want to, well, now maybe it's better that I describe what I want to do, actually. Okay, as I said, someone reserved the Yellow House for the first half of August. They want to delete the first day of reservation. Okay, I can do it like this. I can specify delete from reservation for portion of reservation. Remember, reservation is the name I defined for the period. Okay, it's written here and it's mandatory. And then I specify from to, okay, and I specify the dates or the timestamps. And I specify the bundle name. Okay, so instead of deleting the whole row, MariaDB should modify it. Let's check if it's true. Okay, the row still exists, but the start date is now 2nd of August instead of 1st. Okay. I can also use a different syntax if it's more comfortable for me. Okay, I can write, for example, the same date in from and to, but in to I can write plus interval 3 days, for example. Okay. So let's try it. Let's select the data. And here it is. The date was postponed again. Now, let's try. Suppose I want to delete only 1 day in the middle of a reservation. Okay. So, someone booked the the yellow house for the 1st half of August, but they want to leave it for 1 day only in the middle. Okay, so they want to have they want to basically split their reservation into 2 parts. Okay, and I'm going to do it with this query. Okay, so basically the difference is that now the 2 dates are in the middle of the existing reservation. Okay, so let's see what happens. Magic! Can you see it? John Coltrane's reservation now is 2 different rows. Okay, with the same UUID, which is why we had to add valid start date to the primary key. And basically, first reservation will be from day 4th of August to day 10, and then the second reservation will be from day 12 to 15. Okay, we created a whole and we split the row into 2 parts, or into 2 different rows, if you prefer. We can also modify a reservation, of course, and so in this case, what we're doing, let me run it immediately. I want to show you the result, actually. So what we do, previously the greenhouse was booked for the whole month by Ornette Coleman, okay? But now we decided that Ornette Coleman, how can I say, gives is the reservation to John Cage for some days in the middle of the month, okay? And we do it with an update. So for some days, okay, in this interval of days, we changed the name of the client to John Cage. And now we have 3 different rows. Okay, first part of the month, Ornette Coleman, middle of the month, John Cage, end of the month, Ornette Coleman again. Cool, right? It's magic. If you need to do it by writing code yourself, it will take much more time than this. I'm sure about that. Now, theoretically, we used all our time, but let me spend just a couple of minutes to explain something very briefly. Sorry, I messed up. So again, if we combine the syntaxes of system version tables and application period tables, we obtain a bitemporal table. A bitemporal table is a case where we have two timestamps to identify when the row was physically inserted, deleted, updated, and two different timestamps to identify time periods. Now, I won't show you any hands-on example, but just one slide. Now, why it can be useful becomes obvious if you consider this case. This is a case of a customer who complains because something didn't work and they think it is our fault, but it isn't. And we can prove it thanks to temporal tables. So in 2018, the customer registers to our website and she lives in Glasgow. In 2022, the customer relocates to Inverness. 1 month later, they order a product, but they didn't change the address yet. Okay, we don't know that she relocated because she didn't tell us. The day after, she remembers about her mistake and she changes her profile in our website. And she actually registers the correct change date, okay? So she actually relocated on May, and we know that. The customer never received the parcel. So our temporal table allows us to track all this technology and point out that the customer didn't communicate her address change to us. Well, she did, but it was too late. Okay, so that's why bitemporal tables are useful. A very final word is about MariaDB. I'm not going to show anything and so on, of course. But if you build temporal tables, well, you have something similar to time series, right? So did you know that there's a technology that allows you to query future data? How's that possible? Well, MariaDB is not a proper database in the correct sense of the word, but it is a virtual database and it is AI based. So what it does is connects to external data sources. There are a lot of supported sources, and one of them is MariaDB. And you can run SQL queries on MariaDB. MariaDB will read the source data from MariaDB. In our case, it will calculate some future forecasts using some machine learning algorithms. And then it will answer our questions, for example, about future sales or whatever we ask. Well, I like to mention MariaDB because we just started a partnership with these guys. We believe a lot in this product, and we believe that it will be extremely useful for our customers and in general for database users who need to make forecasts. Well, almost everyone needs to make some forecasts. Our partnership consists in maintenance of their integration with MySQL. Actually, MySQL, not directly MariaDB, but currently their MariaDB integration is just a wrapper inside, sorry, not inside, a wrapper around MySQL integration. So even if you use MariaDB, you actually use MySQL integration. So if you want to try it, let us know what you think about it, and let us know if you think that we could improve something. And of course, if you need some help with it, contact us or MindsDB. We don't support MindsDB, but we support the integration between MindsDB and MySQL or any other technology that we cover. Okay, that's all from me. Sorry if I talked far too much. I think that Stacy is still listening.
Yes, I'm here, and I think we have a question, actually.
Great.
Can you see it?
Could you read it for me, please?
Does adding system version columns can cause any performance change?
Yes and no. I mean, yes, of course it can, because MariaDB is doing more. But it depends. Well, first of all, it can depend on your use case, because if your use case is mostly reading, well, you won't see any performance degradation. If you write a lot of data, you could in theory, but probably there is still some optimization that you can do. So if you encounter specific problems, I think we can help you to improve performance.
Do we have more questions? If you have a question, you can just type it in the questions and answers tab on your in webinar interface. I think we have also prepared some common questions, and while we are waiting for more of them coming in, we can answer those some of them.
Mm-hmm.
Oh, well, I see a question from David asking if we are able to find the examples after the webinar.
Yes. Sorry. I think you posted the link at the beginning, right? So they should be able to see the link to the GitHub repository.
I think I can post it again here.
Okay. Just to be clear, you will see all the examples that I've run during the webinar, and you will see more examples because I didn't have the time to run everything. Thanks for saying that, David. I think I forgot to make the repository public. I will do it immediately after the webinar, so you will be able to see all the examples. Sorry about that.
We can also send it in the follow-up email for those who want to access the examples.
Great idea.
Yeah. I don't see any other questions for now.
Cool. Well, I don't want to talk even more than this, so I talked enough. Probably people have to work now, so let's free them.